Hello, everybody. So today we're going to continue our discussion in Chapter 2, Section 6. And in the previous video, we're talking about how we combine functions together. And I showed you how to add, subtract, multiply, or divide functions. Today's video is going to cover how to compose functions together. And it's a little bit different than what those other four previous combinations that I showed you are, in that instead of combining them on their exterior, we're actually going to take one function and we're going to insert it into another function. So that is what is called a composed or a composition of functions. And the notation to do that is fairly straightforward at first, but when they use this extra notation here, it can be a little bit tricky. So I'm going to explain to you what the initial notation looks like and then how to write it so it's maybe a little bit easier to understand. So it says another way of combining two functions is to form the composition of one with the other. And it says, for instance, if you have a function f of x equals x squared and then g of x equals x plus 1, the composition of f with g is right here. Now look at that notation. That notation isn't terribly hard to understand. You can see that they took the g of x and they put it inside the f of x. And the way that is pronounced is that is read as f of g of x. And so what that means is we're going to take this x plus 1, which is g of x, and put it inside f of x. The easiest way visually to see this is we're going to take this g of x function and we're going to insert it right in there for x into f of x. And so what you end up with is what is called a composed function, f of g of x. Now, the way that they will most often notate this is with this right here. You can see it almost looks like fog, but the O is very small. It's actually a very small circle, and what that means is f of g of x. So if you do see f of g like that, that wants you to do f of g of x, which means put g of x inside f of x. So the first letter is always the first one that's listed here. In a similar fashion, you will be asked in later parts of this to do g of f, and that is simply g of f of x. So you can see f of x is the one that's going inside g of x this time. So this just shows you what basically I showed you. It's called the composition of a function. F with the function g is f of g of x, which is equal to f of g of x. And it does state that the domain of f of g is the set of all x's in the domain of g such that g of x is in the domain of f. Now that gets to be a little bit tricky, but what they're saying here is because g of x is going on the inside, the numbers that you're allowed to put in g of x have to be numbers that give you outputs from g of x that are allowed to be put into f of x. And that's a little bit confusing, and we'll talk a little bit more about that here in subsequent videos. So let's try composing. So the first example, it says, given f of x equals x plus 2 and g of x is equal to 4 minus x squared, find the following. So the first thing they ask us to do for part A is to find f of g of x. So the way I set this up, the first thing I want to do is write it so it's easier to understand. So you can see g of x is going on the inside, f of x is on the outside. So I start by writing f of x, but in place of the variable, I'm going to go ahead and put a big set of parentheses. So it was x plus 2. Now what I'm going to do is I'm going to substitute g of x inside that set of parentheses, which in this case is going to be 4 minus x squared. So now the initial setup of the problem is done. That's usually the hardest part for students. The next part is just to use PEMDAS, or not even really PEMDAS, just combine your like terms and simplify everything as far as you can go. So in this case, the parentheses really aren't doing anything. So we would write negative x squared, and then we have a 4 and a 2, which turns into 6. So our final answer there is negative x squared plus 6. Now, the next one is g of f. So if I write this out, g of f of x, that, you can see f of x is the one that's going on the inside, and g of x is the one that's on the outside now. So I'm going to start with the g of x. I'm going to set it up as kind of like my scaffolding or my outline. You can see g of x is 4 minus x squared. So I'm going to write 4 minus and then parentheses squared. Inside that set of parentheses, I'm going to insert f of x. In this case, f of x is x plus 2. Now we need to simplify this. Now, in order to simplify this, you can see you have x plus 2, the quantity squared. So that's going to need to be FOILed out. So when I FOIL that out, I'm going to get x squared plus 4x plus 4. Now, once that's FOILed out, that negative is going to need to be distributed to everything. So it's 4 minus x squared minus 4x minus 4, just like that. And then the last thing is going to be to combine our like terms and reorder so it's in standard form. So we'll have negative x squared minus 4x, and then we have a positive 4 and a negative 4, so those cancel. And there's our final answer for part B. Okay, the last one asks you to do g of f of negative 2. So what they're saying is find the composition g of f, and then once you find that composition function, or that composed function, plug the number negative 2 into it. So we know what g of f of x is. That we just found is right here. Okay, so if I were to write g of f of x, that function is negative x squared minus 4x. Now they want us to find g of f of negative 2. So I'm going to go ahead and substitute negative 2 in everywhere where there's an x. And then the last thing to do would be to follow PEMDAS and get that down to a single number. So the first thing we would do, parentheses, there's nothing to do inside the parentheses. Next would be exponents. So negative 2 squared would be 4, but then we still have this negative on the outside right there. So this is going to be negative 4 and then plus 8. We multiply those two together. Negative 4 and negative 2 is positive 8. And lastly, we would get positive 4. So there's 3 examples of how to compose 2 functions together. Now I am going to show you one more example. This example is probably a little bit more involved just because each of the functions have a little bit more going on in them. Something to keep in mind is when we do, let's say we had to do g of f, which we do for the second part. So I'm going to take this part and put it in here for x. If this was another 1x plus 4, not only would that 2x plus 5 have to go in for the first x, it would need to be distributed or substituted in for the other x. So remember, when you're taking one function and you are substituting it into another function, that first function has to go into every place that there is a variable in the second function. Students tend to forget that whenever they're setting these problems up. Okay, so we're going to do f of g of x. So you can see, once again, the f is the outer function and the g is the inner function. So I'm going to start with the outer one. I'm going to set it up kind of as my outline, 2x plus 5. In place of the x, I put a set of parentheses. And then within that set of parentheses, I'm going to write g of x, which is 4x squared plus 1. Now the 2 would be distributed, so we would be left with 8x squared plus 2 plus 5, and 2 plus 5 is 7, so it's 8x squared plus 7. And there we go. It's all done. The next one, g of f, we're going to set it up in a similar fashion, although the g comes first and then the f. So the g is my outer function or my scaffolding. So I'm going to go ahead and write that with a set of parentheses where the variable is. If there's multiple variables, you'll have multiple sets of parentheses. And then I'm going to go ahead and substitute f of x in, which in this case is 2x plus 5. Now, before we can distribute the 4, we have to square. PEMDAS says exponents before multiplication. So we need to FOIL 2x plus 5. So when I FOIL 2x plus 5, I'm going to get 4x squared plus 20x plus 25. And if you need to FOIL that by hand, go ahead and do that. You can do that off to the side and do some scratch work for that. Now the 4 is going to get distributed to everything. So it becomes 16x squared plus 80x plus 100 plus 1. And the last thing to do is to add up our two like terms right here, 101. So it'll be 16x squared plus 80x plus 101. And there's our final answer for part B. Now, the last part asks us to find g of f of 1/2. So that it's important that if you have a problem like this, that you know what the function is, g of f. In this case, we did just find g of f. This is the function g of f. So if I write g of f of x, but I'm going to substitute, well, let me just write the function first, and then I will substitute that in for you. Whoops, not 100, it's 101. So now I'm going to do g of f of 1/2. So everywhere where there's an x, we're going to go ahead and put a 1/2. Now, you have to square 1/2 first. 1/2 times 1/2 is 1/4. So we're left with 16 times 1/4 plus 40 plus 101. 1/4 of 16 is 4. And 4 plus 40 is 44, and 44 plus 101 is 145. And so there is our final answer. So that's what I have for you today. I hope that made sense to you for composing functions. And as always, if you have any questions, feel free to email me. Have a great day.